Alright, so let's go ahead and continue. We have, now, number 1's an old one. Number 2 is going to be kind of a different one there, so we'll take a look at that in just a few moments. But let's kind of review compounded continuous interest. The principal of $1,000 is invested at a 6% rate. So they gave us the principal and they give us the rate. Find the amount after 10 years, so they give us T if compounded. And then they're giving us N's. So 1 is monthly. So that's telling me N is 12. Remember, N is the number of computations, compounding per year. So if I want to find out the amount, I'm just going to plug it into my compound formula. It says A equals my principal, which is 1,000, 1 plus R. Now remember, we always write R as a decimal, 0.06 over 12 to the N times T. 12 times 10. Now I'm going to simplify this a little bit here using my calculator. I want to show you something. I want you guys to understand something here. 1 plus 0.06 divided by 12. We get 1.005 to the 120A. Now what I want you guys to notice is this formula right here. This is our geometric series. A sub 1, R to the N minus R to the N. This is our geometric formula. So we have actually been doing geometric formulas for a long time. We just don't ever see it like such. And if I simplify this out, basically it's telling me what's going to be, how much will it be worth. Now, so I get 1,000 times 1.005 to the 1/20th. And that gives me 18, 19, and 40 cents. Now, but unlike before, it's not asking me, well, I guess it is asking me, so what's the amount after 10 years if it's invested monthly? So that's how much we will have in the bank. Now, let's take a look at daily. Here, N is 365. We'll go 365 days in a year. We do the same thing. 1 plus 0.06 over 365. And I'm just going to write this as 3,650 because that's 365 times 10. Simplify this a little bit. 1 plus 0.06 divided by 365. Ooh, really tiny. So I'm not going to worry about simplifying this, but I am going to raise that to the 3,650, and then I'm going to multiply that by 1,000, not 100, times 1,000. And we get, so if we compound it daily, we get $1,822 and, what's that, 3 cents. Now the next one, it says continuously. Now continuously is our Purdy formula. A equals P e to the R T, where E is kind of like your little, E to the R is like your little rate there. So we get A equals P 1,000 E to the 0.06 times 10. And we just type that in our calculator. We like continuous, much easier to work with. 1,000 E to the 0.06 times 10. And we, oh wow, it's almost the same as if we did it daily. We should expect it to be about the same. We get another 9 cents if you compound it continuously versus daily. Very easy to do. So let's take a look at example number 2. Han Solo wants to deposit $100 at the first of each month. A little bit different because he's now not just keep saying $100 and letting it stay. He's going to be continually put money in. So for those of you who have a savings account, we're not going about that part. For those of you who have a savings account, this is probably more models what real life is all about. Han Solo is going to invest in an initial $100. So there's our A sub 1. Well, not A sub 1 necessarily. That's how much his initial investment is for each month. And they give us the rate 6% compounded monthly. We want to find the balance after 4 years. We want to find the balance. We want to find, therefore, the total amount. Therefore, this is a series. It's a sum. As a matter of fact, it's also a geometric series. So this is a geometric series. And because it's only up to 4 years, we know that it is finite. So the equation we're going to use is this one. S equals the first term, 1 minus r to the n over 1 minus r. That's our formula we have to use at the end. So let's think about what we need. First, we need a sub 1. Well, how do we get a sub 1? Well, the first amount that that's the first time we compound it. So that's after the first month. So this is our compound interest formula. This is our compound problem. So we're going to use where a sub 1, or P is 100, R is 0.06, N is 12, but T is 1/12. Now why 1/12? Well, mainly because we only want at the first month. So to get a sub 1, it's going to be 100, 1 plus 0.06 over 12. Now n times t is just 1. And if you type this in the calculator, we get 100. We already know that's 1.005 to the first. Now notice, this is our r in our geometric series. So a sub 1 becomes $100.05. So after the first compounding, after the first month, ignore all of that, ran out of room for an early example. Now since we got our first term, now we can plug it into our formula. Well, what do we need? We need a sub 1, which we got is 100.05. We need n. Now to get n, it's 12 times a year for 4 years, so that's easy. That's 48. And we need r. Well, that's what this number is right here, this 1.005. That's our r. We got that from our first term right there because it's a growth rate. So if I plug it all into my formula, we get 100.05 times 1 minus 1.005 to the 48 over 1 minus 1.005. And we're going to type that very slowly in our calculator. We get 1 minus, just do the top, 1 minus 1.005 to the 48. Remember, only the 1.005 is to the 48. Enter. Divide that by, in parentheses, 1 minus 1.005. Enter. And I'm going to take that answer and multiply by 100.05. So at the end of 4 years, we will have $5,412.49 in our account. Try this one more time, okay? And then we'll go on to number 3, okay? That's a pretty hard one. That's the hardest they get. So let's take a look, and then we'll take a look at number 3 real quick, okay? All right, our last example. A mathematician walks into a restaurant and orders a glass of water. Another mathematician walks in and orders a half of what the previous one ordered. A third mathematician walks in and orders 1/2 of what the second one orders, and so on and so on. The waitress gets tired of this and pours 2 glasses of water, and the question is, why? Now, to answer this question, we have to take a look at the problem. We have the first mathematician walks in, he orders 1 glass of water. The second one walks and orders a half a glass. The second one would be 1/4 of a glass, and so on and so forth. So the question is, why does the waitress pour 2 glasses? Well, obviously she's adding them to infinity, right? So this is a series here. So the question is, what type of series is it? Well, my r is 1/2, so it is geometric. It's our geometric series. And from earlier we learned, and because it's going on forever and ever and ever, this is our infinite geometric series. So our rule is to use this. Our formula for infinite series is the sum equals the first term divided by 1 minus r, where my first term is 1, and we get 1 minus 1/2, which is 1/2. Invert and multiply, we get 2. So even though we are continuously ordering half and half, getting half and half and half, the waitress says, oh, well, if it's an infinite series, I can just pour 2 glasses of water, and that will cover all of the infinitely many mathematicians. All right, so there is a part 3 today, and I would encourage you to go to it to just look at what's the difference between a divergent and a convergent series, and it's only about a couple minutes long. Thank you.